Okay, so Linus recorded that he basically created the first kernel in 1991 under the open source model, meaning it's free, it's open for anyone to use. And it was started as an x86 chip architecture and now has grown to incorporate many different hardware configurations. There is a graphic here that talks about all the Linux OSs from open source to still Linux entities, but models that align with support. For example, Red Hat. Red Hat has a Linux distribution, and they do charge for it, but they charge for it because they've made a bunch of security enhancements to that distribution, and then they offer support for industry, enterprise. So take the time to get a chance to look at this, research about the different names. IBM, for example, Sun Oracle, Theo DeRock, OpenBSD, Dragonfly, Matthew Dillon, Billy Joy from Berkeley, the first when he was at Berkeley, creating the BSD version. So there's a lot of history here to where you kind of know where it starts to where we're at now. Sorry for the phone call in the back. All right, the second thing is, what is Linux? And Linux is an open source operating system created in 1991. Open source means the source programming files, including the kernel, shell, and applications, are available for downloading and viewing by anyone. So you as students, you as instructors, have the ability to download Linux, use it at your will, as long as it's not considered malicious in intent. I strongly advise using the Kali Linux distribution. That has a lot of security tools, and you'll see that in the Oracle Box CyberOps workstation. You'll see a lot of the tools that are in here will actually be some of the same that's in the Kali Linux distribution. There are many different versions of distributions or distributions of Linux, and a distribution is defined by its kernel as well as its program and software packaging. Again, we just talked about this. Some Linux distributions are free, CentOS and Fedora. Others, like Red Hat Enterprise Server, it does cost money. It's not cheap, and it does include support services. But for entities in industry and enterprise who are dependent on a Linux operating system for the core part of their organization, they align and they budget for items such as support services and things like that. All right, so what's the value of Linux? First, Linux is often the OS or operating system of choice in the SOC, or the Security Operations Center. Linux is open source, means anybody can acquire it. The Linux CLI, or the command line interface, is very powerful. It allows, basically, it's extremely powerful, and it enables analysts to perform tasks not only directly on a terminal, but also remotely. The user, as an administrator, or known as the root user, has more control over the OS compared to entities and OSs like Microsoft. You can have an administrator account, but there's only so much you can do to it. With Linux, you have full rights to the entire OS, everything surrounding that Linux distribution. And it allows for better network communication control. The OS can be tweaked and adjusted in any specific way that aligns with the business that's using, or the entity or the user that's using it. Okay. All right. So this one, Linux in the SOC, flexibility provided by Linux is a great feature for the SOC, Security Operations Center. The entire operating system can be tailored to become the perfect security analysis platform. And this is where I just talked about the Kali Linux. Some of the few tools often found in a SOC are the network packet capture software. An example of that is Wireshark. Malware analysis tools. Those tools basically detect malware detection and allows analysts to safely run and observe malware execution without the risk of compromising an underlying system. IDS, intrusion detection systems. These tools are used for real-time traffic monitoring all traffic going in and traffic going out. Firewall. Everyone should have heard of a firewall. If you're not using and have a firewall turned on at your home, on a personal computer or even in industry. You are opening yourself up to the world, and there are a lot of bad people. So firewalls are the necessity for every computer system. The firewall or the software is used to specify based on predefined rules where your traffic either coming in or leaving your network. And this is both on an enterprise and a personal or home use. Okay. Log managers, they log files basically to record events. Large networks create a very large number of events, log entries. So log managers are employed to facilitate log monitoring. That is sometimes a tedious task, but the smallest item of issue can save companies millions of dollars. Log managers are very important. SIEM, or SIEM, Security Information and Event Management, provides a real-time analysis of alerts and log entries by network appliances such as an IDS and a firewall, and a ticketing system. If you've ever seen a help desk system, or if you called Microsoft, if you called Linux, and you spoke to a support engineer, they are going to automatically create a ticket to start documenting the item. I consider a ticketing system as a way to track and control what's going on in real time, along with escalating issues that can't be corrected now, escalating to the proper engineer, whether it's tier 1, tier 2, or tier 3 engineer, to get it completed and get it corrected. So not only you eliminate the issue for the user that's calling, but also document it and implement any changes in the overall system or overall Linux distribution, so it doesn't happen for other users or other enterprises or home users. Here are the Kali Linux. The Kali Linux tool category, I strongly advise downloading this just to look at it. Again, I say that lightly, just to look at. The Kali Linux tools can be used for great learning and as a great educational tool, but this distribution was basically created for SOC analysts. It has SOC specific tools to do penetration testing for checking for vulnerabilities in the network, or identify a computer attacking it. It has packet generators, port scanners, proof of concept exploits, and these are examples of pen tests. So I advise strongly use it for education, not something for malicious use, because government frowns upon that, and there are laws that frown upon that. And even in your school that you're at now, in my school that I'm at now, community college, when we do a pen test, it's known if we do a pen test in our technology building, we're going to get a call very quickly, not only from our security expert on site. Our CIO is going to make a very quick march up here and want to know what's going on. And then we take that information that's been identified, we give it to the CIO, the security expert, or security analyst that's on site, and they can fix the vulnerabilities if any are identified here on our campus. Now, we do that, and that's kind of a known thing, kind of a pat on your back, hey, we're going to see how you're doing. But for you as students, I strongly advise work with your instructor before you do any type of pen testing at your institution. All right, the Linux shell. This is basically the user's way of communicating with the OS through a CLI or GUI. Linux often boots into a GUI, just like, I'll back it up here. This is a GUI interface, and then you would have the ability to select terminal or the command line, which would give you this look here. Now, this is Red Hat or Ubuntu, so you can see some of the things here. It's talking about it's doing the LS or listing documents here. And these are the permissions for that particular document. Let's see. So in this figure, look at this. We can actually, this link, if you do not have access to a Linux command line, you can actually select the link. I like the top one, it's the x86. Start it up. And this is a web interface for a live Linux virtual machine, okay? Hosted by bellard.org, that organization. So I can do information such as directory. I can do lists. I can list, there's a DOS folder, there's a hello .c file. So I can concatenate, or basically cat, which will show what's actually inside that hello.c file. So I'm concatenating that information onto the screen for me to view. So it tells everything about it. I can't do a cat to DOS because that's a directory or a folder. So I'd have to do a change directory DOS, and now I can do a directory or a list and see what's in there. Now I have a .com, ASM, .debug, HPIGOT, .s files. So that's just an example of how to go in and play and actually do live, real information, even from the man pages. What I'm going to look, what information for the manuals and stuff. We'll get into some of those commands and that here very shortly. Back up here. Hold on. Okay, so you'll hear different terms, basically around shell or console, and I'm right here, console window, CLI terminal or command line interface terminal, and terminal window. They're used interchangeably. They all mean the basically same thing. It's just the command line. It's the interface. It's the shell. So just kind of understand that's what a lot of different terms are used for the Linux shell or the CLI here. But here, these are just basic Linux commands. I can go through them verbatim, or I can just kind of read them, and I'm just going to talk about them. So each one of the commands here have a different output. So MV, move, I can move or rename a file directory. CHMOD, change mod, I can modify a file permissions, or I can change, basically modify a file. I can do a CHOWN, I can change the owner of a file. DD, I can copy data from input to an output. PWD, print working directory. Where am I at physically in that Linux distribution? Okay. PS, processes are currently running in the system. SU, I can simulate a login as another user or to become a super user, and that goes into sudo or sudo. Run commands as another user with super user abilities. Let's get one ahead. Other basic list command, Linux commands. grep, I can go out and I can find and push the output, maybe a text document, to a different document. Okay. If config, that basically will give me the network interface information. What parameters are set, whether it's DHCP or static. Another one is shutdown, password. Change the password for a current user. There's cat. We just talked about cat, short for catenate. List contents of a file, basically on the screen that you're looking at. And then the man, used to display the documentation for a specific command. So if you know what the command you're wanting to do, you don't quite understand what its function or purpose is, you can type cat man, and it will tell you everything about the cat command for you to use in the proper way it's designed to be used. All right. Let's see. Okay. So here's some other ones. LS for list. I can display the files inside a directory. I can change a directory. I can make a new directory. CP for copy. MV for move files from one directory to a different directory. I can remove files. And here's grep again. Searches for specific strings of characters when a file or other commands or other command outputs. And then cat. Concatenate what information very quickly onto the screen. Any questions so far? If you do, please type them in the chat window. I'm monitoring them on the left side of my monitors, so please stop me anytime. All right, so here's the Nano text editor. Linux itself has many different text editors with various features and functions. Some text editors include a GUI or graphical interface, while others are command line only. You may have heard in there's some studies going on right now that a lot of OSs are moving away from the graphical user interface and going more to command line only, just because that is securing systems better. I don't know how that's going to work in the public industry, such as the home user. I know, for example, if I were to tell my wife you're no longer going to have the Windows key and be able to use your mouse and move around, she'll take the computer and never use it again. So there will be a pushback from a lot of entities, but for the security expert, that is the importance of knowing, or for the future security expert that you all are all going to be, the benefit of learning the command line is invaluable for now and in your future job opportunities. Okay. All right. So let's see here. Okay. All right. Importance of text files in Linux. In Linux, everything is treated as a file. This includes the memory, the disk, the monitor, the files, and the directories. For example, the OS, from the OS standpoint, showing information on the display means to write to the file that represents the display device. It should be no surprise that the computer itself is configured through files or configuration files. Okay, they're stored. They're usually text files used to store adjustments and settings for specific applications or services. So here we're going to look at, in the Nano text editor, the etc host file. So we're going to have 127, which is the loopback. 127.0.0.1 is aligned to the local host, and 127.0.11, which is still a loopback address. It's assigned or aligned to the Kali host, which is basically the Kali Linux entity. And then you can see what the local loopback addresses are for IPv6, or the local host IPv6 from FS02::1 and ::2. So that's just a minimum output from the /etc/host file itself. Okay. Now, one thing to know here is if you go in as a basic user and you go to this file, you will not be able to make any changes to it. You have to go in as a super user or a root user to make any changes to files such as the host file here. So the administrator commonly uses the sudo nano /etc/host to open the file, and that command sudo, which stands for super user do, invokes super user privileges for that text editor to open and edit that file as needed. Okay, so you will see sudo and you'll see su, super user, quite a bit in Linux, but just be aware of where you're at and what login you're using or moving across from default user to a super user. All right, so this lab, you're working with text files. It's over here. Basically, you're going to get familiar with Linux command, line text editors, and configuration files. So if you do not have the CyberOps workstation, all the labs in this course can be completed inside this VirtualBox, inside that CyberOps workstation. So please take advantage of using that and using this workstation as much as possible. So your part one, you're going to be working with graphical editors. Step two, you're going to be using the SCITE, which is a text editor built into the CyberOps workstation or into this Linux distribution. So please get familiar using that. Part two, again, using a command line text editor. You're going to SSH into an aforementioned computer via graphic shell, graphic interface. Let's see what else. You're going to edit the nano space.txt. Then you work with configuration files. This one right here, the ls-l command, that's going to list in detail both the file name or the folder name along with who the owner of that file is and what permissions is aligned with that particular file or folder. It even tells you how large it is and the date it was created, date and time it was created. Okay. This ls-la gives even more information. Here's the permissions, the owner, of the file, the date it was created, how large it is, and then if it's it goes all the way into the basic root directory. So please take your time, go through it. For these labs, they're going to be a lot of just verbatim. You can go through and do this lab very quickly, but the point of doing the labs with this is read what the command is asking you to do. This is the most important step with this in this lab and the next 5 labs in this chapter is don't get into a habit. And I tell this to students, and I tell this to my kids at home, both my boys who are in college, and I still pride myself to read as much as I can, even though reading is not always a strong suit of mine. Read what it's asking you to do, type it, and then say, okay, this is why, this is the output, but ask yourself questions, research it, practice again. So practice does make you better, and sometimes practice does make equal perfect, but don't just assume that, okay, I can do this thing and move on, because at some point in time, these basic commands you're doing in here will come back to you, and you'll have to know them, and you have to remember them, because when you go sit for the certification exam, or you're sitting in front of a interview committee, they could ask you something. What's the ls command? Give me your description or definition for ls command. You may have used it 1,000 times, but if you don't know what it's the actual definition of it does and how to use it, you're going to bomb out with that interview. And sometimes it just takes one bad item in an interview to really change the attitude towards hiring particular individuals. So you want to go in prepared not only for school, you want to be prepared for your certification exam, and you want to be prepared for the next steps in your life for a position, for a job. Okay? All right, so no questions so far. We'll continue on. So I'm not going to open this one. This is just getting familiar. Again, this is practice this labs, basically the same way. Read it, understand it, and then once you feel comfortable, move on. All right, so the introduction. This is an introduction to client-server communications. This is very similar to Word or Windows, how it happens. Servers are computers with software installed that enables them to provide services to clients. So this server has services that it's providing to this client, from files that this phone is pulling down over the network, to telephone directory, just to information in general. So this is considered a client-server communication process. Resources are stored here on the server, and the client is in itself is a hardware, software. Yeah, I'm in class now. It's going to be, sorry class, it's going to be 30, 45 more minutes. Okay, sorry for the interruption there. So here the clients themselves are hardware, software, and understand that it can a client can be considered software, and it's a combination that people use to directly interface or interact with the files here. This one is one that I strongly like, the common port number in services, not only because this was part of CCNA 1 and 2 classes, but this is an important part of a security operations center, is knowing what traffic is aligned to what port number, and then verifying that if the traffic that's actually coming across and using a port number is that type of traffic, because there is such a thing as called port hopping, where you would have HTTP traffic jumping across over to FTP traffic, or FTP traffic jumping across maliciously over to HTTP traffic. So I strongly recommend look at these here. There are many, many more, but these are the common ones, from FTP, Secure Shell, SMTP, DNS, POP3, MTP, Network Time Protocol, IMAP, SNMP, HTTPS. Now, I can tell you that, and I can just go to the next screen, but for you as students, you have an opportunity here to dive in and learn it a little stronger, a little more than that. So this is kind of an off-topic thing, but this would be a prime example of using external resources, whether it's your CCNA class, if you're in the CCNA classes, or even Google, what is FTP? Read FTP, read what a Secure Shell does, because you can pull up the actual full pages about the port number and about the service, and you could read for a whole day on SNMTP. I mean, a whole day on DNS. But just open it up, look at it, and do a little more research about what each one of these items do. Okay. So a client. I mean, a client's pretty self-explanatory. Clients are programs or applications that are designed to communicate with a specific server, also known as client applications. Clients use a well-defined protocol to communicate with the server, and the well-defined protocol is those port numbers that are right here. So are we going to access a web page using HTTP, port 80? Are we going to do it? We're going to need a secure web page, HTTPS, port 443. So be aware, web browsers are web clients. So you can use HTTP protocol. FTP, port 21, client is the software used to communicate with an FTP server. Okay. Lab Linux servers, we'll look at this one. So here, again, you can use the CyberOps workstation virtual machine. You're going to log into the command line of the terminal or the icon here. So we'll open up, go to here, file. Let's see, I'm sorry, applications. There's your terminal editor, and that's how you would get to the terminal editor in that virtual workstation or the virtual box. Okay, and then you're going to actually display the processes that are currently running on there. So you would sudo, which I hope everyone knows, sudo is the super user do. So you're going into the root account and saying I need to have root privileges to see the current processes that are running, and then the -elf function beside it. I would say do a ps man first, and it will tell you what each one of these are and what their function are. Well, we'll just do it. That's that. Yes. All right, so I actually had it backwards, man, then PS. It shows the current processes. You actually hit the space bar to go through and look at them. So with ELF, to get info about threads, PS-ELF. The E stands for select all processes. Somewhere here. F is they do full formats to list it out fully. And then L is going to display it in a long format, or the BSD long format. Okay, so I'll do escape or Q, and then do sudo. What was the command? Sudo ps-elf. It's going to ask for the password. Password should be CyberOps. And now I can expand that out, and I go through and look at every single process. And you'll notice that when I ran the PS, or the current process is running, it only showed 2 as a generic user. I did a ps-man. That showed me only 3. And now with the super user or the root account, I can see every single process, the process ID, who the name, the entity, the time, even the timestamp for that particular process. Okay, you'll see some that says root user to access that, HTTP. So all I can say is just use this lab, again, as a practice entity to learn the commands. If you're your instructor, I'm not sure your instructor will require you to do this, but I would say do this on your own anyway. Answer the questions to the labs. Why is it necessary to run the PS command as root? Well, we just seen it. We needed to see the full list of processes, not a non-administrator list of processes. Okay, so go ahead and do that lab. All right, service configuration files. In Linux, the services are managed using configuration files. Common options are port numbers, locations of hosted resources, and client authorization details. So figure 1 here shows a portion of a configuration file for NGINX, a lightweight web server for Linux. So basically, they use the cat or catsnake command and it cat, and then went into the file. They said, I want to cat the item that's inside the etc folder, the nginx folder, and I want to concatenate or show on the screen what the hg, I guess it's the hg, or nginx.conf, okay? So it basically pulls that information out for you to see in a quick, easy format. Item number 2, they're going to do the same thing, but they're going to list the full etc NTP configuration file. So you'll notice some of the items here have a pound sign in front of them. Those means that when the process goes through and it's looking to say, all right, I'm going to align these items, it's going to skip anything with a pound sign in it, but it's going to say server 0.arch pool. We're going to use that as one of the NTP pools. And here's 4 of them it's going to use, okay? It's going to say restrict certain addresses, 127.0.1. That means it's going to restrict the loopback address, okay? Figure 3 here is going to do the same thing. It's going to out to the snort .configuration file. This shows the configuration file for snort, which is a Linux-based IDS, or intrusion detection system. It tells you everything about the snort configuration file. You can just read through it. Again, Linux is a great operating system, and Cisco is taking advantage of importing this information in here and allowing you to scroll and actually see the full configuration file. So please take advantage of using that and scrolling through and reading the items that are available to you. All right, so hardening devices. If I had more voice, I would ask questions and stuff. But here it's talking about the process which involves implementing proven methods of securing the device and protecting its administrative access. Some of these methods involve maintaining passwords, configuring enhanced remote logins, implementing SSH. Defining administrative roles in terms of access is another important aspect of securing infrastructure devices, because not all IT personnel should have the same level of access to infrastructure devices. Okay, so best practices. These best practices have been developed by a conglomerate of people, conglomerate of organizations that you need to do this. Other organizations are going to say, hey, this is a problem. You need to do this if you truly want to harden a device or you want to make it secure. The only true secure device for any, whether it's Linux, OS, your cell phones, anything IoT, is it just basically disconnect it from the network and it never connects to anything else. That's the only true 100% secure device. So be aware of that. However, there are steps to get you as close to that 100% security, and these are some of them. From ensure physical security. Who has access to what? Minimize install packages. For the install packages means what updates are available, and your administrators or your security administrators, are they monitoring those install packages and then only pushing out the ones that make minimal changes and does not cause a security threat to the enterprise or the user, and it doesn't give excess privileges to anyone that does not have the necessity for it. Okay, you'll hear the term least privilege a lot with security. You want an individual or you want a computer to have the least amount of privileges to be able to get their work done on a daily basis. If you give them the least amount of access, the least amount of administrative access to get their work done, and they can still complete everything they need to get done, then you have done your job as a security expert. Okay. Some of the other ones are disable USB auto detection, enforce strong passwords, force periodic password changes. For me at the community college, we have both a strong password policy and periodic password changes that are required. It's not an option. I have to do it. Right now, our minimal password size, I think, is 8 characters in length. We got one uppercase letter, one lowercase letter, one special character, and we can't use the last 5, or maybe I don't think we can use the last 20 now. I don't know, something like 20 passwords. And then, even though I may have changed my password today, I may be on a schedule that I have to change it every 45 days or every 3 months. So I may change my password today, and then come in tomorrow, the system will say you need to change the password again because it's your time to change the password. So periodic password changes means that passwords can change at any time. All right. Monitoring service logs. This is the var log syslog file. This basically are records that a computer stores to keep track of important events, specifically about the kernel, the services running on the operating system, and the applications that are running on that system. And every one of these, from the kernel, the services, and applications events, are all recorded in log files. So it is very important for an administrator to periodically review the logs on a computer to keep it healthy. By monitoring these files, an admin gains a clear picture of the computer's performance, its security status, and underlying issues. So in Linux, log files can be categorized as application logs, event logs, service logs, and system logs. Okay. And here are some of the very popular Linux log files. So you'll notice that everything is var in the folder var / folder log, and then these are the configuration files and where these files are located. So please just go through and read these. One that you're looking at here is the syslog file. Each line here represents a log event. The timestamps at the beginning of the lines mark the moment the event took place. So you could have a computer, or you could have an event happening, and an administrator is going to look at the time. When did the problem start happening? Well, it may have been a week ago. It may have been 24 hours ago, or three hours ago. So they can go back in the var log syslog file, go down back 3 hours, 24 hours, and start looking, all right, what's going on? What happened? So very good information, but please read through there, through those items for our clear understanding. Okay, here's a lab locating log files. You're just going to go through and you're going to see, you're going to generate. This is a single log, so you're going to look at web server logs. This is in the CyberOps PC. You can actually go and do the cat or concatenate the var folder, the log folder inside of it, and this logs tutorial.log, and you can read the information about that particular web logs itself, okay? And then look at some operating system logs. Locating log files in unknown systems, okay? Let's see what else. Again, and I say this as far as I can, take your time, read it, understand it, because right here, this would confuse me if I was sitting here for the first time just saying, please go back and read it, but I'm curious about why that highlighted. Well, that's highlighted to say that this is that file that you're looking in, okay, the etc nginx nginx.conf, and these are permissions. There's a read-write for the owner and a read-read for both the user and again, basically others, okay. This is the ls-l or ll command. There's a tail command which will let you display the end of a log file. So if I do sudo, which I'm using superuser or sudo as superuser do, so I'm saying I'm a superuser, and I want you to show me the end items or the last items that are in this file, and that's what it's going to pick up. So instead of having to look through that entire log file, you can look at the last 10, 12, 15 items in it. You can even go back and say, I want to look at the last 5. This, I think, is 10. This using a -n or number, the 5, okay? Here, -f tells to display the end of a given text file in a terminal window. So just please go through that and look at that. If you have any questions, I'll put my email address, and actually I'll do this now. Feel free to email me any questions that you have that doesn't make sense, and I can send you a video for further clarification, okay? All right, file system types in Linux. So there are different, just as it says, there are different file extensions. ext2, it's the second extended file system. This was the default file system in several major Linux distributions until it was supplanted or updated to ext3. This is a journal file system designed to improve the existing file system. A journal, or the main feature that is added, was a technique used to minimize the risk of the file system for corruption in the event of a sudden power loss. So a sudden power loss means that the OS is not going to be messed or basically be damaged. Okay, so you don't have to use it. If you're familiar with the Cisco, you don't have to use that copy, run, start, or CP command to save your commands, because if you lose power on a Cisco router or switch and you're working in, all that information is gone. You have to go back through the configuration process. All right, so let's see, ext4. This was designed as a successor of ext3. It was created based on a series of extensions to ext3 to improve performance and increase supported file sizes. So as ext2 to 3, let's see here, ext2, let's see, it was limited to a lot of smaller file sizes. ext3 went up to a file size or file system of 32 terabytes, and ext4, let's show it in it, even went larger files. In the NFS, Network File Systems. NFS is the network-based file system allowing the access over the network. CDFS, Compact Disk File. This was created specifically for optical disk. Swap system is used by Linux when it runs out of RAM. It is a swap portion that does not have a specific file system but is irrelevant. When this happens, the kernel moves inactive RAM content to that swap partition on the disk, and while the swap partitions are known as swap space, can be used for Linux computers with a limited amount of memory. So it allows for the system itself to heal itself in a general sense, to keep it from crashing, keep it from running slower. Okay. Here's HFS Plus, which is Hierarchical File System Plus. It's used by Apple in Macintosh. MBR, you should have heard of MBR. This is located in the first section of a partitioned computer. Stores all information about the way in which the file system is organized. Okay. Mounting is a term used for the process of assigning a directory to a partition. The figure here is you're going to mount command in the Cisco CyberOps VM, and when issued with no options, mount returns a list of systems currently mounted in the Linux computer. So these are all the items or files that are mounted in that particular Linux distribution or Linux computer. Linux roles and file permissions. In Linux, most system entities are treated as files. In order to organize the system and reinforce boundaries within the computer, Linux uses file permissions. Here it's using the ls-l, the list command with the L parameter as an additional information about the file. It's considered the output in here. So it's telling us ls-l space.txt file, giving us the read, write, execute options for the user and the owner. So you have RWX, the first set of characters for user permission. So you have RWX for the first user, that's read, write, execute. Okay. The second set is for group permissions, that's read, write. And the third set is for any other user or group, and they only have read. So the first one is the user analyst who owns the file. So you're going to normally have a higher, more options. Mainly, you're going to have that execute, whether you can read the file, you can write or change the file, and normally the X is to delete the file. So the only user, the owner of the file can make those changes. The group's normally going to have a read write if they're in a particular group, and the last group, if any other user or group, will have just the read permissions. Third and fourth display field here is analyst and staff. The analyst is the user and staff is the group. and they have 253 bytes in size. The 6th field is the date and time, and then the 7th is the actual file name and file type. Okay. So here are the file permissions. You have the first is 0RD. This is the file or directory bit. Indicates it is a file. D, it is a directory. Okay. So dash or D. Okay. Then here's the user, the group, and other. All right. So in binary, this is what it looks like with what permissions. So 000 would have dash, 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 meaning they do not have any access for read, writing, or executing the file. In 111, if you would see that, it would have read, write, and execute capability. Okay. All right, hard links and symbolic links. Use the command ln to create a hard link. The first argument is an existing file, and the second argument is the new file. So we're going to basically link space.text to space.hard.text. In figure 1, and the link field now shows 2. Okay. So now we do ls-space with the asterisk, meaning anything, any type of file or any type of name that says space whatever after it, it will show you what's listed in that particular directory that you're sitting in. And now you'll see both the space.text and the space.hard.text. Okay. Figure 2, we're going to echo hello world to a file called test.text. Then we're going to link the -s, that test.text, to my test.text. Then we're going to echo it's a lovely day to that. And then we're going to go more, which more is more test.text. When you do that, it shows what's in there. Hello world, it's a loving day, because we're in the test.text file. And then we'll do more, it's my test.text, and it's basically the same thing. Hello world, it's a lonely day. We did a hard link to both of them, where it linked both of them together. So the next one was remove. Remove test.text. So basically delete it or remove that file. Type that more command back in, and now it's saying there's no such file or directory found. And then we can use a ls-l my test.text, and this is what comes up. There's your read, write permissions, analyst staff, my test.text, test.text. Okay, that's just the hard link, but the file itself is gone. Okay. So here's a lab, navigating the Linux file system and permission settings. So you can go in and you're going to block devices. You can display file systems currently mounted. Please answer the questions, whether you're doing it for a grade or doing it for yourself. That way you understand what you're doing here. Using the change directory option, then the ls, what else? And then reviewing and visualizing and changing file permissions. So you can actually go in as a super user and change the file permissions for this file for read, write, execute for either the user, the group, or other users. Okay, what else? We do this, just doing the ls-n, ls-l. Here's a compare. Here you're going to compare permissions of a malware directory, the mininet_services file. Some symbolic links. You can do block files, character devices. You can pipe files, symbolic link files. Files used to link to other files, socket files. So there's a different options and different types of files. So please read through those. And I do apologize for all the ringing in the background. All right, so X Windows System. This is a graphical interface present in most Linux operators or Linux computers. It's based on the X Windows System, also known as X or X11. X Window is a Windows system designed to provide the basic framework for a GUI. X includes functions for drawing and moving windows on the display device and interacting with a mouse and keyboard. X works as a server, as such allows a remote user to use network use the network to connect, start a graphical application, have a graphical window open on the remote terminal. While the application itself runs on the server, the graphical aspect of it is sent over by X over the network and displayed on the remote computer. So it's basically just a remote link into a desktop for that. The KDE window, so you have GNOME and then KDE. All right, so one is the GNOME window manager, and here is the KDE. So you can look and select the different options. Actually read more into GNOME, what is GNOME, what the releases are, learn more about it. And here is for KDE. So just read about it, products, everything about it, okay? I'll have to do that kind of outside the context of this particular today. All right, the Linux GUI. So when you log in, you have different options. At the very top or here, you have the launcher. You have the top menu. You can actually go through and highlight the plus signs, and it'll tell you more about it. So the launcher is a dock placed on the left side of the screen that serves as application, launcher, and switcher. You can right-click any application to access a short list of tasks the application can perform. Okay. So the top menu is up here. Multi-purpose menu bar containing the running application. Buttons control the active window and system controls and notifications. Here's your system notification window right here. Many important functions are located here in the top right. Use this to indicate switch user, shut down a computer, control the volume, or change the network. Actually do a dash search box. It's a search box here, search tool for recently used applications. And then a quick list down at the very bottom. You can right-click any of the application here on the launcher to access a short list of tasks the application can perform. Okay. So here is a Unity desktop in a web browser. So this is an Ubuntu desktop. So we basically can go here. We'll show ourselves around. It's pretty quick going in. That means that the network connection from here to the Ubuntu.com website is pretty awesome. So I can go through here and just use the Ubuntu text option here and look at everything, look at system settings. So take advantage of this. I mean, you can see that I've got all the options up here from, let's move this out of the way, from shutting down, the date and time, to the volume. I can tell others that I'm busy, okay? But this is a very basic entity or installation. That's only going to give you so many features. They've turned off a lot of features, okay? So please take a look and go through that Ubuntu online tour. Installing and running updates or running applications on Linux. Many end-user applications are complex programs written in compiled languages. To aid in the installation process, Linux often includes programs called package managers. A package is the term used to refer to a program and all its supported files. By using a package manager to install a package, all the necessary files are placed in the correct file system location. There are several package managers. For this course, you'll use the apt package, or a few of them is called the apt.get update. So you're going to use application or advanced packaging tool. You're going to go out and use apt-get and update command. This will fetch the package repository and update the local package repository. So there's an online or linked repository that keeps all the updated information. And before you install an application or another installation, whatever you're deciding to do, you're going to update your existing local list of it. And then after you've done that, then you're going to upgrade your existing system. So the apt-get upgrade is used to update all currently installed packages to their latest versions. Pretty easy, really easy to do. Sometimes it is time consuming. So if you're running a PC or a Linux entity or installation, and you don't have to have it being responsible for doing any type of task, yeah, do the update and the upgrade. However, make sure you got enough RAM, enough to complete the process along with enough storage, because you will have additional storage requirements for the updated packages. Okay. Keeping the system up to date. Again, this is to apply patches. OS updates are released periodically by the companies to address any known vulnerabilities in the OS. While companies have update schedule, there are releases of unscheduled OS updates that can happen when a major vulnerability is found. When modern OSs will alert the user when updates are available for download and installation, but the user can check for updates at any time. Go to app-get update command, upgrade your system, app-get upgrade command, or you can manually check by going to the dash search box, type software updater, click the icon as shown in the figure here. Okay. All right, processes and forks. So a process is a running instance of a computer program. Multitasking operation systems can execute many processes at the same time. Forking is the method that the kernel uses to allow a process to create a copy of itself. Processes need a way to create new processes in multitasking operating systems. Thus, the fork operation is the only way of doing so in Linux. Forking is important for many reasons. One of them relates to process scalability. Apache, a popular web server, is a good example. By forking itself, Apache is able to serve a large number of requests with fewer system resources than a single process-based server. When a process calls fork, the caller process becomes the parent process, with the newly created process referred to as its child. After the fork, the processes are to some extent independent processes. They have different process IDs, but run the same program code. I read that verbatim because that is a very important topic to talk about, how processes duplicate themselves, okay? So here are a few commands to manage the processes. PS, used to list the processes running on a computer. The top, TOP, this command is used to list running processes, but unlike PS, top keeps displaying running processes dynamically. The only way to stop it is the Q for quit, to exit it. And then you can actually kill a particular process. This command is used to modify this behavior of a specific process. Depending on its parameters, kill will remove, restart, or pause a process. In many cases, the user will run PS or top first before running kill. This is done so the user can learn the process ID of a process before running the kill command. Now, that was a lot to kind of go over, but that was verbatim, and it needed to be because that is very pertinent and necessary information, not only to learn Linux and how Linux operates, but that is literally certification-worthy information. All right, malware. Linux malware, and you don't hear about it a lot because I use mainly Windows. I don't hear it about as much as my Linux specialists do. But Linux malware includes viruses, Trojan horses, worms, and other types of malware that can affect the OS due to a number of design components, such as the file system structure, file permissions, and user account restrictions. Linux operating systems are generally regarded as better protected against malware. I would say they are a lot stronger and harder for malware to actually attack. Even though it's possible and it's happened, understand that Linux isn't immune. Many vulnerabilities have been found and exploited in Linux. They range from server software to kernel vulnerabilities. Okay, so if a malicious program is executed, it will cause damage regardless of the platform. A common Linux attack vector is its services and processes. Vulnerabilities are found in server and process code running on computers connecting to a network. Prime example, a network is connected to a network. Any device that's connected to a network is vulnerable to a malware, basically bad stuff. It's vulnerable to a security issue, security vulnerability when it's attached to the network. The only secure one is the one that's not attached, and that's not productive, and it's hard to say I'm taking this computer off and I'm just going to use it. Well, you can do Word programs, you can do certain things, but you're limiting what that device was intended to be used for, okay? So here, this figure shows an attacker using the telnet command to probe the nature and version of a web server. The attacker has learned that the server in question is running in Nginx version 1.120, and the next step would be to research known vulnerabilities. Okay, so he telnetted character, came back with this information, and it was telling it was running this Nginx 1.12. Once that end user had access through telnet to that, which was telnet is open, non-secure. Once they realized what operating system it was running, the next thing to do is they're going to research that and say, all right, what can I do next? What's a known vulnerability that may have not patched this system? Okay. Rootkit check. All right, a rootkit is a set of software tools designed to increase a user's privileges or grant access to portions of software that should not normally be allowed. Rootkits are often used to secure a backdoor to a compromised computer. Installation of a rootkit can be automated, done as part of an infection, or an attacker can manually install it after compromising the system. Rootkits are terrible. They're destructive. They will do harm without any repercussion. Okay. Rootkits can hide with intrusion. They can remove installation tracks. They can even tamper with troubleshooting and diagnostic tools so that the output now hides the presence of the actual rootkit. Okay. While a few vulnerabilities through history have allowed rootkits, the vast majority of rootkit compromises require root or admin access. Okay. Rootkit removal can be complicated and often impossible, especially in the cases where the rootkit resides in the kernel. And that would require a reinstallation of the OS, which is usually the only real solution. So you could do a check rootkit. It's a popular Linux-based program designed to check the computer for known rootkits. It's a shell script that uses common Linux tools such as strings and grep to compare the signatures of core programs. It also looks for discrepancies as it traverses the /proc or proc file system, comparing the signatures found there and the outputs of the PS. So here you can select this link and it will tell you more about the check rootkit command. So locally checks for signs of a rootkit. So here it is. There's the check rootkit file that you could download, put it on your system, and then link it, and then run that rootkit check on your system. Okay. Piping commands. Although command line tools are usually designed to perform a specific, well-defined task, many commands can be combined to perform more complex tasks by a technique known as piping, named after its defining character, the pipe. Basically, the backslash holds the shift key, and it's the pipe that's above it. For example, the ls command is used to display all files and directories of a given directory. So here they use the ls-l command. So here they were able to see everything in that particular file structure. The ls-l /grep nimba, that nimda, they only wanted to see, only wanted to pull any file that was named nimda, okay, and that's what they did. So that was a quicker way, faster way to only pull the necessary files instead of having, and this is very small, a lot of directories, a lot of servers. I mean, you're looking at thousands and tens of thousands of text documents, folders. So having the ability to use the pipe command and grep and pull only the files and folders you need is very beneficial. It's very time saving by doing that. The video demonstration, I'm going to let you watch that on your own. It's only 4 minutes and 45 seconds. So either after this presentation or at home where you're at, please watch that video demonstration about applications, rootkits, and piping commands. And that is the end of this particular lecture. And I'm going to see the participants. I'm going to unmute everybody. Any questions so far? I'm sorry, Bayside. I just now seen that you arrived. Sorry about last week. That was my fault. Kelly was out of town at a conference, and I thought the meeting was Wednesday, and it was actually Tuesday, and I had it the wrong date on my calendar. So I take full responsibility, and I do apologize. Anybody have any questions? Any concerns? Okay, so stop sharing my desktop, and I'm going to. All right. Since there are no questions, Kelly will be back in contact with the next round. I don't know the next date that the next topic's going to be covered. I know we're getting close. Kelly will come up, I think May 5th. I think that's where he's at. He'll actually be bringing Brandon for the first introduction, and then the competition in June sometime. So good luck to everyone. I do appreciate your patience and taking the time each and every Tuesday that you've been doing this. It shows them not only for you as instructors, but you as students, you have a willingness to learn and make yourselves better and make the area you live in better. So I look forward to seeing you in person in June, and hopefully in another meeting or two online. So if you need anything, my email address is pcrump7001@stanley.edu, and have a great and wonderful rest of your day.